So, another important concept I need to share. Already we have developed these equations, right? Uh, just I want to draw some diagram. Please remember this one. In the first class lecture only, we told some. One second. Voltage, sinusoidal voltage and all. And in transmission line, I told the length should be very high. So once you draw the diagram for the transmission line, make sure the length should be very high. Don't draw like a simple circuit. Uh, let's say this is the transmitting, transmitting, and this is the load, right? Load impedance. And look here, the length is very high. So this is the length L. Now we are letting X is minus L. Why? We are telling this is the generator side. This is the generator side. Now today, I explained some reflection, right? Already I told, na? You just remember this is medium 1, this is medium 2. So some traveling wave is falling here, some is reflected back, some it is transmitted. So this is your transmitted, this is your incident, this is your reflected, right? Same thing is happening over here. This is the receiving end, or we can write the traveling wave, where it is traveling. Where it is traveling? It is traveling here in this direction. So it is traveling towards the generator. That's why we have written this is minus L, and we are placing this L equals to 0. This is your origin. Since we are writing this generator, we are keeping generator means this is your origin only, where the signal is generated and it is traveling towards your generator. This is your transmitting it. This is your origin, this is your generator. And that's why it is written minus X direction, because look here, the length we are taking that one, this is L equals to 0, it is traveling opposite thing. That's why we are putting minus L. That is the main reason. Now, already we know that V equals to V plus e to power gamma. Acha, I'm writing the same equations. It will be easy for you. V plus e to power minus gamma x plus V minus e to power gamma x, correct? Now place x equals to minus L. What it will come? V plus e to power gamma L plus V minus e to power minus gamma L, correct? Very simple. Similarly, I, we can write this is nothing but I plus e to power minus gamma x plus I minus e to power gamma x. What we can write? This is nothing but V plus by Z naught e to power plus gamma L minus V naught, V minus by Z naught e to power minus gamma L. Just we are writing x equals to minus L. We are just putting this equation. So we are getting these two equations. Please remember. And y minus, because the traveling wave is traveling in the minus x direction. Here is the generator. We are putting this is L equals to 0. It is flowing like that towards the generator. Okay. And we have substituted x as minus L. Now, what will happen at the boundary condition? Today in the physical class also I told about the boundary condition. If you remember, that's why I told, na, if you understand today's class in normal incidents, it is very easy. Same only. Boundary condition, what I told, Z equals to 0. If you remember, what you will put here, L equals to 0. That is your origin. This origin is your boundary condition. Now you put boundary condition. boundary condition. What we are getting? Boundary condition is nothing but L equals to 0. Your origin is your boundary condition. Now place L equals to 0.
Bottom equation, this should be plus, no, sir?
This one.
The middle sign. V plus C power gamma L by Z naught plus I equal to.
I equals to this one.
Yes, sir. Why did it become minus, sir, in the middle?
From here to here, you are telling?
Yes, sir.
1 second. Already I told. Look here.
V minus by I minus is minus Z.
This one. Z naught is nothing but minus V minus by I. If you substitute, it is coming minus. Okay. You please check, huh? Check the equations. Z naught, what I told, it is minus of V minus by I. That's why this minus is coming. Okay. Is it clear? Now place the boundary conditions. What we will get? Same thing. V is nothing but V plus it will be gamma L plus V minus it will be minus gamma L. Now L is equals to 0. So it will be coming V plus V minus. Similarly, I, what you will get? Something like 1 second. It will be V plus by Z naught by this one, right? V plus by Z naught minus V minus by Z naught, or we can write 1 by Z naught V plus minus V. So this is coming, correct? Now, let's say this is one equation. This is another one. Now you divide V by I. This is called ZL. Why ZL? V by I is nothing but your resistance only. We are representing by Z. But why ZL? Because L equals to 0. What resistance is there? ZL only, na? Load resistance. So that's why V by I is nothing but your load impedance, we can write, not resistance. Load impedance. It is equals to what? It will be cancelled, right? Not cancelled. V plus V minus divided by something is coming V plus minus V minus and 1 by Z naught. So it will be Z. So ZL is coming Z naught into V plus V minus divided by V plus minus V minus. I think it is understandable. Right? So load impedance is related with your characteristic impedance and what? Traveling wave or traveling voltage in forward direction as well as negative direction. So it is a function of Z naught, V plus and V minus. Please remember, your load resistance is a function of Z naught, V plus and V minus, not your I or I minus. Right? Now again, I'm introducing some parameter. Same thing what we are doing. Reflection coefficient. Today only I told. We are writing gamma L. Gamma L. This gamma L we are representing as V minus e to the power minus gamma L divided by V plus e to the power gamma L. Why this ratio is like that? it is a ratio of backward wave to forward wave. Please remember that one. It is a ratio of backward wave or backward voltage wave, whatever you want to write, to forward wave. I think you know about the reflection coefficient. What I told that maybe reflected by incident, something I told, na? Reflected by incident. So forward is nothing but your incident. Backward is what? Your reflected. Same thing we are doing. So backward by forward. Now, what is your gamma L at L equals to 0? It is nothing but V minus by V plus. Or we can
Sir, back would be B minus e power plus gamma.
V minus minus gamma L. I'm writing.
Why so?
I'm writing in L only. Look here. I think you have confused with this X. X we are putting as minus L, na?
Yes, sir, okay.
So that's why. If you can write in terms of X, it will be plus. X is minus L, it is minus. Huh? So we can write gamma L0 is nothing but V minus by V plus. Please remember this one. At the boundary or at the origin of the reflected wave is nothing but what? The ratio of what? Voltage, backward voltage divided by the forward voltage. Now we already know ZL is nothing but Z0 V plus V minus divided by V plus minus V minus. Correct? Now can I represent in form of this gamma L? Is very simple.
Yeah.
This is 1 plus V minus. Can I write like that? You check. I am dividing by V plus. So these two, these two are what? This is gamma L naught. This is gamma L naught. So can I write ZL is nothing but Z naught 1 plus gamma L naught plus 1 minus gamma L. Another important relation we have derived. Right? So what is the meaning of that one? It means how much energy is reflected from the load end of the transmission line compared to what was incident on the line. Now, beautiful relationship. How much energy is reflected from the load line? You see from here. How much energy it is reflected from the load line compared to what it is incident. That is your reflection. Obviously, that is your reflection only. So this ratio denotes that one only. All these things are there in the notes. I think if it is clear, just one simple thing, I can say. So this is the relation between your load impedance and characteristic impedance. And with respect to reflection coefficient, I have given all are important for your numericals and everything. And if you prepare for gate levels and different competitive exams, so this reflection coefficient, load resistance and everything, 100% some questions will come. Now, what is your gamma L? It is equivalent to gamma naught. It is nothing but ZL minus Z naught divided by ZL plus Z naught. That already I told, huh? Acha. I didn't told. You can prove that one. How to prove? Look here. ZL equals to Z naught, 1 plus gamma naught, 1 minus gamma naught. Correct? From there, you can easily prove. Still, I'm doing. Look here. ZL by Z naught is nothing but 1 plus gamma naught by 1 minus gamma naught. From there, how we can do? You do ZL plus this plus 1. So it will be coming what? So this will be cancelled. This is minus gamma naught. From there, we can get 1 minus gamma naught is nothing but 2 divided by ZL Z naught plus 1. Please follow. So gamma naught is what? Gamma naught is 1 minus 2 divided by ZL by Z naught plus 1. So what it will come? Check. It is coming 1 minus 2 into, let's say, Z naught, ZL plus Z naught. So it will be coming ZL plus Z naught. Okay, it is coming. I think all of you got what I told, ZL minus Z naught. So this is the derivations. From there, you will be getting a relation between your reflection coefficient and the load resistance and characteristic efficiency. Very important relation, right? If in the question it is given that load impedance is given, characteristic impedance is given, find the reflection coefficient, 100% one question will come. So it is nothing but ZL minus Z naught divided by ZL plus Z naught. And from where we have done, this is the proof. Very simple. I am doing this and this only. Okay. Now just last thing I want to say. What is your matched condition? What is your matched condition? Matched condition means when ZL is equals to Z naught. It is almost analogous to your maximum power transfer theorem. I think you have done or not. It is there in circuit theory. Maximum power transfer. Your Thevenin resistance is equals to your equivalent resistance. I think if you remember that one, that is similar. Characteristic impedance is equals to your load impedance. Then we can say the condition is matched and this is equals to what? 0. This is 0 means what? Maximum power transfer, you remember. How much maximum power you are transferring means there will be no reflection. There will be no reflection. No reflection. Nothing is there. Reflection of power on the transmission line. So this is called matched condition. When load resistance and characteristic impedance is same, then we can say there will be no reflection. Whatever it is transmitted, it is traveling to there. So this all about our today's class. If any confusion is there, you can say. We have completed up to the matched conditions, characteristic impedance,